Hello React Native developers, I hope you are well. William here, recording from beautiful Zurich, Switzerland. Last week, MKBHD released the MKBHD 251, and that reminded me that with great products should come great transitions, and it inspired me to build this nice slider in React Native Skia. So each transition is a Skia shader, so we use GL transitions from Gael Renaudot, but repurposed in React Native Skia to have these nice transitions. And then we leverage the UI thread level integration between Reanimated and Skia to use the gesture handler and be able to detect the gestures nicely. So here we use the new composability in gesture handler 2.0 to nicely detect if I'm going from here, I'm sliding to the left, or if I'm sliding to the right. So I'm using a different transition. And in gesture handler 2.0, these are extremely easy to build, and before basically was not really possible. And also the Skia shaders in React Native Skia are nicely composable. So using all these components together makes it a really fun project to build, which otherwise would be, I would say, quite complex because these GL transitions have been built to run on only one side, basically. And so a really, really fun example. And there is another YouTuber, Dev2D, which had a little bit of fun and painted the MKBHD 251. And of course, what you can paint in real life, you can paint in Skia. So it inspired me also to build a small shader where we can rotate the hue of the picture to have different color variations of the product. So now let's dive into VS Code. We are into VS Code here, and I have a boilerplate project which you can download from the video description in case you want to code along. And I have actually coded quite a bit here. I have a gesture handler which drives the progress value, which drives the progression of the transition that you see move here, right? So we simply divide by the width of the screen to go from 0 to 1. And we also clamp the value, but this you can decide. And we use a snap point function to know when we release the gesture based on velocity, so which we always need to divide by width to know where to snap if we snap in 0 to 1. And once we know where we need to snap, we use an animation to do it. Maybe it should be faster, I think. Oh, 255 maybe is fast enough. Then we have our Skia shaders. So we pass the two images, right? This one and this one as parameters. We can select different transitions. So maybe here I can switch to some other transition. Oh, I need to reload, I guess. So this is a page curl transition. And that's pretty much it. So we're going to do this in 3 steps. So the first step is going to be, we're going to take some shaders from the GL transition project, and I'm going to show you how easily this can be translated into React Native Skia. So we go from the GLSL shader language to the Skia shader language, and there are some small differences we need to account for. And the second thing is that we're going to make the gesture so that we can go to the next page, and so we could go to more than one page, and then that we, in a way where we could go back also to the previous pages like you saw in the introduction. So let's get started. Here we have the GL transition project, and we have the gallery of transitions, and we can pick any transition, and this one is actually pretty cool, I'm seeing. So I converted already a couple of transition using, but maybe this one looks fun and it looks complex. So that should be an interesting one to migrate. The more complex the transition is. But basically, let's look at a simple one maybe first. And this one is simple enough. So there is a transition function that needs to be implemented. This is where we write the transition, and it assumes 3 things: that there is a progress value that goes from 0 to 1 that gives us a transition. And then there is a get from color to get the position of the texture at the start, and get to color. And if we go into the code here, and I go into the transition. So I have a base shader here where I have image 1, image 2. So that's the from and to color. This is great, and that's done on purpose, that GL transition let us implement these interfaces and doesn't do it automatically because maybe we have to deal with these images have different resolutions and things like this. Here they all have the same resolutions, but it allows you to customize if needed. And also here texture access is different in Skia, is using a different syntax than in GL. Here we're going to insert the code that implements the transition function. And again, this is where using React Native Skia is pretty cool because we can compose code and that will generate our final shader. And we simply invoke the transition function in the main function. So already here I have migrated some transitions. We can do maybe a simple one and a more complex one, and then we'll go into the gesture handler. So let's take maybe a simple one. Is this one simple? It looks simple. Okay, so this one, very simple. So I'm going to copy the code. So I'm going to create a new file, and it's called simple zoom. So I'm going to call it simple zoom. And so this is the code of my shader. So I'm going to create an exporter variable called simple zoom. And I'm going to use the GLSL tag. So here the name of the tag is random. It's just because I want the syntax highlighting. So I defined, let me import it. I defined these two tags, one that returns a string, one that returns a Skia shader, and I used these two names. The two names are unfortunate. I just use these names so the VS Code extension recognizes the syntax highlighting. Probably it can be configured, but so here we implement the transition function that looks good. So you could, because we can generate the final shader code, right, using TypeScript, JavaScript, you could have like extra parameters to deal with, like clamping. You see here, you can adjust, but yeah, I'm gonna make it a const. Here we are hitting already one of the difference from Skia and GLSL is that I think the compiler is gonna complain because this one, you can only have constant literal expressions as constant values, so you're not allowed to write this statement, I think. But that's okay because this is where the variable is used, so we can move it here. And so that looks correct. So now let me use this as a transition. So here I have my list of transition. Let me add simple zoom. So here, this is the transition. So I'm going from 0 to 1, 1 to 0. So really simple one. We did eat a small edge case. Let me do a more complex one, and then we will go into the gesture. And I think we saw a complex one, which is this one. And yeah, let's try it. I haven't played with it yet. So this is live, no safety net, but so it's called stereo viewer. So let's create the file, stereo viewer.ts. Okay. Let's copy paste the code. Let's see what happens. Really curious. But at least it gives you, maybe we're going to get into some shenanigans, but it gives you a sense of how easy it is to. So here is a const. So this needs to be I mean, it could be a uniform. I decide to make it a const for simplicity. Okay, so this one so far so good. These are perfect. Actually, it might be a lot of code, but it might actually be a very simple one to migrate. So is it just going to work out of the box? Oh, let me import it here. Uh, okay, so ratio. So this one I think should be, let's have a look. Where is it? So corner size. Oops, sorry. And ratio is not. I mean, here I know that I can maybe create one value of 1 because we know. Yeah, okay. So that was an easy one to do actually. So we had one undeclared variable, but that's a fun one actually. But I would say the main difference, we didn't hit too many edge cases, but the main difference is that in Skia shaders, they really want to have when compiling the shader, know that it can execute at a certain speed. So some dynamic expressions are being removed. So we often need to rewrite the code so that everything can be statically inferred. I can give you an example. So I think the page curl here. So there were a dynamic expression computed as a variable, which was called amount, this expression here, simple expression, and I had to inline it in every function where it was used because I couldn't get it outside. But this is also where JavaScript can help us to, because we can dynamically build the code sometimes. So now let's get into the gesture handler. So if I go back here, so we have our fun transitions. What was simple zoom cube? So I'm having the list here. And so everything we do for the left, we are going to do for the right. And this is where gesture handlers composability and Skia composability make this job really, really simple. So let's get started. I think this is really, really fun because otherwise that would be really, really hard to build. But so progress left, progress right. We go symmetrically. And pan left, pan right. So I'm just going to copy this code here. And here I'm going to change the values. So this becomes positive. Progress left becomes progress right. Oops. 0, 1. So this should be good. Uniform left, uniform right. Progress right. And so this is the part which is interesting. So which gesture we do? So we do a race. So between pan left and pan right. And this is where gesture handler 2.0 is extremely powerful because suddenly I can decide for the finger to move a little bit before deciding which gesture I want to activate. So for the one going on the left, I want to add activate offset X of, let's say, minus 10 points. So I don't activate, oh, is that, maybe that's a lot, right? Maybe 5. And for the right, 5 on the other direction. And so we'll wait for the finger to move a little bit to know which of the two we can activate. So this is really fun. And now what do we have here? So we wrap, so we have our transition shader. And again, this is where the Skia composability comes in, where we can nest shaders together. So I'm going to maybe use this one, transition 1, transition, so 0, transition 1. So this is our first argument, and the second is going to be a third image. So 0, 1, 2, okay. Actually, should be probably, is this correct? Or maybe it should be 0, 1, 2. Something like this, maybe. And I forgot to close. Let's have a look. So here I'm seeing the right image. I'm going back to the first one. Okay, and can I go to the next one? No, it's not working. So am I only activating? Okay, I'm only activating on the right. Oh, okay. Of course, here we need to use the uniforms on the right, hopefully. So I'm going back and I'm going forward. Isn't that cool? But now what we need to do, so now once we finish the transition, everything is broken. And so what we want to do is to have an offset to remember where we are into the list of pictures. And so what I did is that I had a React state originally, which is the offset. So when we finish the transition, we say, okay, now we moved backwards or forwards. And that works great-ish. The problem is that as soon as now we have like some rendering, which depends on, and then we need to reset the animation values. And this is where things get a bit hairy, because suddenly we rely on some sort of synchronization between the Skia rendering, the reanimated rendering, and the React rendering. And here these are like done completely separately. There is no way really to synchronize the React state with the animation values. So we're going to render everything using reanimated, because then it's going to be always perfectly in sync. Using a state, it kind of worked, but sometimes you would like have a frame. For one frame, the animation state and the React state would be out of sync. So that's not good. But if we do everything with reanimated, it's going to be perfectly in sync. So I'm going to have an offset variable to remember where we are. And when we finish, let's say, the animation here, so we have a callback. What I want to do, I think, is to increase. No, to go to -1. So to decrease by 1 the offset. And increase it by 1 when we go to the left. I think this is correct. We'll see. Okay. Uniforms, this is correct. But now everything now needs to depend on these offset values. So we're going to need to create one derived value so 5 derived value, 2 for the transitions and 3 for the images. So bear with me a second. So we have transition 1, use derived value. And we return transitions at, yes. So here I have an add function, so I can always access whatever values, negative, positive, I can always access the array, and it rotates around the array. So here I would do offset value -1, and transition 2 is offset value. Okay. And here, of course, I don't need to, sorry. This is transition up. So I use the add function to always pick the proper value in the array. So this is transition 1, transition 2. Same for asset. So asset 1 is offset value on assets. And this would be this one. Yeah, let's assume It's not, is it gonna cry? Maybe should I return null if? I think should be okay. Let's see. Here, yeah, I think it's gonna be fine. So I can. Okay, yeah, that's good. Asset 2 is offset at value, which I can place here. And asset 3. So we use reanimated again, everything will be as offset +1, everything will be nicely synchronized. No glitches, hopefully. That's last famous words. It's already glitching. Yeah, because of the null value, that's okay. So if array is null, we return null. Okay. Okay, let's have a look. So it's not working very well. I think here when we, and also when we move the offset, and that's the synchronization that I was talking about, we need to set the value back to 0 once we change the offset. And so originally when I wrote the code, offset was a state, and so this was an animation value, and it kind of worked, but not really. I mean, it worked, but sometimes you could have a small glitch because the renderings here were done separately. Here it's all nicely synced, so I can do it also for the left here, and hopefully it should work nicely. So I'm going to the next, I'm going back, next, and you see how fast it is. Like, this is why no glitches, no drop frames. This is why we want to do everything with reanimated on the UI thread and with Skia. So a really, really fun example. Guys, I hope you enjoyed this example. There were a couple of things at play here. First, we used the GL transition as Skia shaders. So I'm really glad that we get to reuse these shaders on our React Native apps. We took advantage of the gesture handler 2.0 new composability to really build something a bit more complex, because these GL transitions, they were designed to only go in one direction and one direction only. And we took advantage of the reanimated free UI thread level integration with Skia to bind the two together in a really, really performant way. If you are coming to Krakow for appjs.conf, I will see you next week. But regardless, I am looking forward to talk to you soon. And until next time, happy hacking.